as you know, we are going to discuss about secure coding proactive controls. So for the next 75 to 90 minutes, we are only going to talk about how to make our product secure. To start off, a quick introduction from me. I'm an AppSec consultant at Thesis, a global payments company based out in Pune, India. I have a background in network security, VAPT, secure code reviews, and security audits. I code in Java, .NET, Python, and Ruby. I'm a security author at pluralsight.com. I have a video published last year. The next video is coming in a couple of months. I'm also a security podcaster at testkills.com, and I'm into the security field for more than 10 years now, and mostly into the BFSI domain. So agenda for today's session is to provide overview of secure coding guidelines for developers. And using the OWASP proactive controls, we will first define the control, then see a few code snippets like the unsafe and the safe ones. And of course, we will see how to secure our code. So to start off, think in your mind, who as per you is a secure coder? Now I have an image of a salmon fish on the screen. So for me, being a secure coder is like a salmon, because you might know the trait of salmon is it goes upstream or it swims upstream against the tide. So for me, being a secure coder is like being like a salmon, so that you go upstream against the traditional coding practices. Most of the organizations believe that the delivery is more important. So when you focus on the delivery or the user friendliness, you tend to loosen up the security. So we want to make a product which is secure as well as user friendly, and how to make it is what we're going to discuss in the next 75 minutes. Now, these are the 8 proactive controls which OWASP has given. There are actually 10, but I haven't included the top 2, which the first one is security requirements. So OWASP has an application security verification standard, that is ASVS for short. It has around 200 requirements related to security. So whenever you're developing a new application, you can refer to OWASP ASVS and take all the requirements that are applicable for our application. And the second one is related to architecture. So if you're an architect, what sort of questions you need to ask yourself as well as a development team is what is mentioned in the second proactive control. The 8 mentioned in the screens are directly applicable for the developers, and hence I have mentioned those in here. They look to be a lot, but I'll make sure that they are very interesting and we understand each and everything. So let's start with the first proactive control, that is parameterize queries. So we'll begin with a joke. So I'll give you like 10 seconds to go through the joke that I have on the screen, and I hope you laugh in the end. It's funny, isn't it? I mean, it's a clear case of SQL injection. This screenshot has been taken from bobbytables.com. Bobbytables.com is a very good website which gives you mitigation strategies for SQL injection for all possible programming languages. So if you're noting down, bobbytables.com is a very good site. Now, for a joke, this is a good thing because in the end, she says, and I hope you learn to sanitize your database inputs, but only sanitization doesn't help to solve SQL injection. So I would say Bobby Tables is wrong in this case. Now why? We will see this with the help of an example. All right, so how many of us would think that this is a valid email address or an invalid one? Now, probably you could think this is an invalid email address because it has a single quote, double hyphens, and an OWASP.com. Some of you might feel this is a valid email address. Now let's consider that I log into an application and I want to update my email address. I go to my profile, update profile, and then in the username section, which is my email address, I enter this particular email address. Now let's say in the backend, there's a query which gets fired when I click on the update button. It looks something like this on the screen. Update user, set the new email which has come from the user, and ID is a random value. When I give the email address mentioned on the screen, the query becomes something like this. The new email would be the email that I've given, and update users set email would be the one I gave. Now, if you could see the single quote at the beginning, now whenever this query reaches the interpreter would try to see where the query is ending. Now we all know that SQL queries end with a single quote. Now because we have given this particular single quote on the screen or in the username field, the interpreter might assume that this is the end of the query, and after that we have given two hyphens, which means comment. So what we did was we ended the query and we have commented out everything after it. So when the interpreter, which might be vulnerable to SQL injection, processes this query, it sets a blank email address as a username. Now, if you go by the regular expressions in HTML5 for email address validations, this is a valid email address. Now, those of you who thought in the beginning that this is a valid, it is right. But in HTML5, if we go by the regular expressions. Now, how do we fix SQL injection? Now, in .NET or in general, SQL injections happen because of dynamic queries. That is, we take all the inputs from the user and just add them in the query and fire it. There's no validation or sanitization happening. It is all dynamic. So what we do in parameterized queries is we build static queries like the name value pairs. Now on the screen, the ones in red is like at the name, at the rate name, and at the rate password are the placeholders that I have created. Now let's say even if I enter a single quote, a Prasad, my name as the username, and let's say a single password, the values that would be passed in the backend would be at the rate name and at the rate password. It won't directly fetch the single quote Prasad and forward it to the database. Now, what happens in here is even if I've entered a single quote, the interpreter would try to see if single quote Prasad is a username in my database. And then it returns back an error on the screen saying that this username is not found or incorrect username and or password. So we'll also see how to give generic error message on the screen in the later part of this session. But this is how we do it in .NET. Parameters.add, the one in bold, is what we used for parameterized queries in .NET. Now, how do we fix it in Java? In Java, parameterized queries are called as prepaid statements. Same technique, but a different name. We use a name value pair. Now here the question mark is our placeholder. And we have taken the set string as 1, which corresponds to the new name, and 2 as the ID. And the query which is fired is update employees set name question mark and where ID is question mark again. I've also given HQL parameters queries example here. Pretty straightforward, but parameters queries has been the best recommendation for SQL injection for like over a decade now. But still, SQL injection is the topmost attack category or injection category in the OWASP top 10. Now that is because a lot of developers focus all their security knowledge or secure coding knowledge on only the critical pages of the application. For example, the login page, or if it's a banking application, they would focus everything on transactions or credit card statements. But they forget to understand that once they log into the application, there might be a search field in the application given to the customers to search for something. There might be a help hyperlink which takes the customer to the help page on how to use the application. Now, most of the times, these are the functions or the pages which are vulnerable to SQL injection because the developers have been focusing on a lot of critical pages and not on the simple pages which can lead to an SQL injection attack. We will see more examples in the next section. Now the next proactive control is encode data. This is very important if we want to mitigate the famous cross-site scripting attacks. Now, let's say if my browser sees this particular tag coming back from the server in the server response. We all know that this is an HTML less than symbol or a script tag. If a browser sees this symbol, it will try to execute it. It won't consider it as a string, but it will consider it as a command which is coming from the server. And that's why it will try to execute anything that you have written after this. Now, if the server sees this, it will definitely consider it as a string and not as a command. So this is an HTML encoded value for the less than symbol that you just saw. That is ampersand LT. LT stands for less than. Similarly, the script ending tag would be ampersand GT. That is the greater than symbol. Let's see an example to understand it much better. Now let's consider the first script. Now what I'm doing here is, let's say there's an application and I'm not an admin, I'm a normal user, but I want to log in as an admin, or probably I want to hijack the admin session. So what I'll do is I will probably host an HTTP server at my end. I'll go to the application where I'm a normal user and I'll enter the first script. Now, then I save it. Then I go back to the admin and tell him that there seems to be an issue with my application. I'm not able to log in. Now to check that, the admin will first log in with his or her credentials, go to all users, then go to my user. And while he is logged in as an admin, he will try to click on this particular script. Now this is a very straightforward script. It just takes the current user cookie and sends it to the site that I have just set up, which is example.com. Now, when the admin clicks on this particular link, his current session ID or current cookie would be sent to me on my HTTP server. Now, once I have his cookie, I can log in as an admin. It is that simple. And the example that I gave was of stored cross-site scripting, where I'm storing a particular script in the database, and anyone who clicks on that script on the application, his or her session ID is sent to me on my HTTP server. Now, output encoding not only saves us or prevents us from cross-site scripting attack, but it prevents us from a lot of attacks like site defacement, network scanning, data theft, and keystroke logging, among others. Now, cross-site scripting is a very interesting attack because you have to be knowing the application and how the context of the input where it is being loaded. The table on the screen gives you a very good example on what sort of defense you should have for cross-site scripting depending upon the context that you're loading the input in. So whatever input that you take from the user, where the context would be loaded, how it will be loaded, the defense depends upon that. Now, for example, if it's your data type is string and your context is HTML body, you will be loading the input in an HTML body. The defense would be HTML entity encoding. Similarly, if it's an HTML data type and your context is again HTML body, you should do HTML validations like JSOUP, anti-SAMI, and HTML Sanitizer. We'll see the HTML Sanitizer in the next session, in the next section. Now, talking about OWASP Java Encoder project. Now, I have seen that when the developers try to customize the encoding part to mitigate from cross-site scripting attacks, they end up making a blacklist, which is not a good recommendation. You should either go for a whitelist, never go for a blacklist. Now, Java provides an encoder project. I've given the link on the screen. It is a very simple library, an open source library. You can just include it in your code or import it in your code, and you have all the possible context in it, and the Java encoder project will encode the values for you. I've mentioned a few contexts on the screen like HTML context, XML, CSS, JavaScript, and URI. We'll see an example to better understand it at a code level. Now, my problem is the web page that I've built in Java JSP is vulnerable to cross-site scripting attack. Now, the solution using OWASP Java Encoder project is on the solution in the green part. Now, let's say my input type is text my value would be encode for HTML attribute, and the data value would be the value that the user has provided. In this case, even the user provides a script, like a script alert 123 and ends the script, that value would be sent in the data value parameter. And because we're using encode for, it will encode everything, and what the server would see or what the browser would see is ampersand LT script and ampersand GT. So the browser would treat it as a normal text and not as a command. Similarly, there are a few other examples as well, like for button click, we can have encode dot for JavaScript attribute. So when you import this particular library in your code, you just have to type encode dot and you will see all the possible contexts, and you can choose accordingly. Very good encoder. I've used it myself. A lot of organizations today use it. Probably the organization that you work for might be using it. If not, I would strongly recommend to go for Java encoder project, then customizing your encoding. Now, Java encoder project is only for Java, but Microsoft already has some inbuilt libraries to protect against XSS. The famous one is the anti-XSS library, which is system.web.secure.anti-XSS. It is like inbuilt, like native .NET library, very powerful and well written. So if you're a .NET developer, you should be using the anti-XSS library to prevent against cross-site scripting attacks. Any questions so far? All right.
Prasad, we'll take the questions towards the end.
Okay, sounds good. All right, the third proactive control is validate all inputs. Now, all is being in caps. It's not a typo, but it's been there like for mandatory purposes, because I have seen a lot of developers not validating all the inputs, as we discussed about the search and help fields. What you see on the screen right now is, on the left hand side, is a tiny MCE editor. Now, those of you who don't know what tiny MCE is, it is an editor which gives you an HTML output on the screen. Now, again, an open source library, you import it, you give it some input, and it will give you an HTML corresponding output for it. Now let's take an example that I have an application which provides reports to the customers. Now the customer logs in, he selects the date range to and from, and in the browser itself, I show him a table where he sees all his transactions, for example. Now I'm loading the HTML context in the browser for the user. Now in this case, if I try to go for encoding, that would be a problem, because the table would come up, because I have been encoding all the script tags, if you remember, like ampersand LT and ampersand GT. So all the garbage value would be on the screen rather than the proper table. Now, in this case, what we can do is we can create a whitelist of the tags, because I'm the developer. I would know that what are the tags that are needed to create this report and show it on the screen to the end user. Now, like on the right hand side, you see certain tags like H1, P, H2. Now, those are the only tags that I need. So I can create a whitelist of all the tags. And even if the user provides a script tag in it, that would be rejected by the server because it's not in my whitelist. So that is why I've mentioned validate all inputs. Now, a lot of times it happens that the developer is in a situation that he has to show something in the HTML context, but because we focus on encoding, we have to save assets from cross-site scripting. Now, that is like a tricky situation. But if you have a whitelist of all the tags that you're going to use, that is the best recommended approach. Never go for a blacklist, else your blacklist would be never ending. Because every day there are new scripts, new tags coming up to perform cross-site scripting attacks, and you might have to just keep on adding them. which is not feasible and not a good practice as well. So it's always recommended to have a whitelist of all the tags. Now, OWASP HTML Sanitizer project is again a great project from OWASP, again for Java. HTML Sanitizer is completely written in Java. You can just import it again and it will sanitize the values. So if you want to make a very secure product, it is recommended to, and it is in Java, then it is recommended to have the OWASP Java Encoder project as well as the HTML Sanitizer project. So both would help in encoding and sanitizing your data. So it also helps us to not go for customizing a code by writing it ourselves. Very high in performance and low memory utilization, which is the best part of it. A quick code snippet for sanitization. The problem is my web page is vulnerable to cross-site scripting because of untrusted HTML. The example that we just saw, displaying reports. Now the solution would be I will create a policy, an HTML policy, and I'll only have the parameters or the values that are whitelisted, and those are allowed in my application. For example, allow elements, allow URL protocols, and in the end, if you see the last line, it will be string safe HTML policy.sanitize untrusted HTML. So anything that is coming from the user would go in the untrusted HTML box for the report generation section. And if the things that the user has provided doesn't fit in my policy, those would be rejected and the user sees an error saying that the report cannot be generated. Please contact your administrator, for example. So this is how you use sanitization, by building a policy and only adding the whitelist in that. There are a few other HTML sanitizers for different programming languages like Python, PHP, .NET, and Ruby on Rails on the screen for you. It is highly recommended to use them in your program language at whatever you code in right now. It's very helpful. Like for .NET again, anti-access .getSafe.html helps you in sanitization. So the anti-access library has both encoding as well as sanitization. The next proactive control is related to access controls. Now, there are a few anti-access controls on the screen which I've mentioned, like hard coding roles or hard coding passwords, access control that is open by default, untrusted data driving access control decisions. So again, let's try to understand access controls with the help of an example. Now, if you have observed, the photos or the screenshot on the screen are from the movie Star Wars. So if you have seen the movie Star Wars, I'm a big fan of that movie. So the four characters mentioned on the screen are the ones that I've mentioned in the code above. Now, the thing that is in their hand is called as lightsaber. It's a weapon. Now, only these four characters are allowed to use this weapon. Now, if I'm someone who does a lot of hard coding in the code, what I'll do is I'll just take each and every role and I'll say if the user dot is role is Jedi, the first one is Jedi, the second one is Padawan, Sith Lord, and JD killing Cyborg is the last one. So if I'm very lazy and I don't like to secure code, I'll just hard code these roles because I know that these are the four people who are going to use this lightsaber anyways. Now let's imagine that I am developing a game for Star Wars and I hard code these values. Now, once the game goes live, there might be some hackers who want to use a cheat code and they would know that these are the four characters who know or who have the power to use the lightsaber. So this is a very bad practice. Now let's say tomorrow the organization that I work for, the gaming organization, is probably taken over by Disney and they ask me to change these characters to the Disney characters. Now if I have tens and thousands of lines of code where I've hard coded everything, I would have to go on each and every line and change the characters. Hard coding of access control is a very bad practice and it is not at all recommended. So how can we do it securely? Now the problem is the web application needs secure access control mechanism. The solution would be, what I'll do is instead of hard coding the role, I will check for the permissions. Now, if the current user who is logged in is permitted to use the lightsaber, then he would be able to do it, else he wouldn't. In this way, I am also hiding the critical users of my application, that if I directly say that my admin name is administrator and I say that user.israel administrator access everything. But if I say that check the current role of the user and then give him the access, that is a better security practice to do, because the attacker wouldn't know that which are the admin users and whom he has to target. So we shouldn't give him a ready-made attack vector to attack, right, to make it more confusing. The next proactive control is to establish authentication and identity controls. Now, this is my favorite proactive control because it is related to authentication, that is passwords. Now, passwords are like heart of an application. We all know that we should have strong passwords, never share a password with anyone. Now, there are a few screenshots on the screen. There's a hash killer, hash cat, cloud cracker, and a GPU. Now, some of you, or probably all of you, would know that these are password cracking tools on the screen. Now, when we say that the password should be hashed, we also mean that they should be hashed with a very strong hashing algorithm. We should never be using an MD5 at the current age, because it is very easy to crack. You can just put it in Google and it will give you the corresponding clear text password. Now, these tools help us to crack such passwords. Now, for example, even if I use, let's say, SHA-512 as my hashing algorithm for my passwords, and tomorrow my database of password is breached or hacked. Now, the attacker has, let's say, thousands of hashed passwords. Now, because it is hashed with 512, it is probably impossible for him to get back the clear text value. Now, what the attacker would do is he would take all the dictionary words, for example, and hash them with SHA-512, and he would compare the hashes. Now, if any of the hashes match, the attacker would know that the corresponding clear text password is your password. That is why it is always recommended to not use dictionary words as your password and instead use passphrases. Now, few of the password defenses on the screen. Disable browser autocomplete. Only send password over HTTPS post. Now, this is a very basic thing, but a lot of applications, if you try to capture the request in a proxy tool, let's say burp or WhatsApp, and if you try to change the method from post to get and pass the password in the URL, the server actually accepts that and you're logged in. This is a very basic thing, but it's not being checked every time. So if you are from a pen testing background, you should always check that when you log into the application, just capture the request in a proxy, change the method from post to get, take everything in the URL and pass it. If the server lets you in, then this feature is missing. This defense is missing in the application. Do not display password in the browser. Trust me, I've seen a lot of applications which don't have input type equal to password. That might sound funny, but yeah, it's a case, unfortunately, in a lot of applications on the internet. Stored password based on the need. Use a salt. Now, salt is a very important feature when we are storing passwords, because the example I just gave about dictionary words. Now, if I use a dictionary word and that's my password, then it's easily crackable because the attacker would have a similar hash value at his end. Now, let's say even if I use a dictionary word and I add a unique value in that, the user doesn't have to bother about it. Let's say I have a dictionary word password as my password. Now, the user enters that, and then we add a unique value to his password and we hash that value. Now, the unique value which I'm talking about is called as a salt. Now, let's say, taking the similar example, now I have a password database, but each password has been hashed with a unique value, that is a salt. Now, even if that database is breached tomorrow, The attacker would never know the clear text corresponding password because he doesn't know the salt. The salt is generated by, let's say in Java, it would be generated by secure.random function. There is a unique value given to each user every time he creates a new password. Now, a salt should be unique to each and every user. It shouldn't be repeating. Now, there is a one more feature that has come up recently. It is called as a pepper. Like we say that your password should be hashed with salt and pepper. Now, some organizations or most of the organizations don't use pepper because unlike salt, it is unique for the entire password database. So it is not really recommended to use pepper at this moment, but it is recommended to use salt, which is unique per password. Now, Scrypt and PBKDF2 are very good password hashing algorithms for password storage. PBKDF2 is very good. Now, HMAC is also another alternative to store passwords. Now, if I have to give an example of HMAC, let's say taking the same example, my password is password. I take a unique value that is salt. I hash them individually, then I combine them together, and then I hash them again. That is called as an HMAC, like defense in depth sort of a thing. So that would be impossible for an attacker to even wildly guess the corresponding clear text value of your password. For password storage, use a cryptographically strong credential specific salt. So if any one of you might have worked on password storage, or if you're a developer, most of the times you make use of the protect function. So protect should be salt and password. Use at least 32 to 64 character of salt. Do not depend on hiding, splitting, or otherwise obscuring the salt. Do not allow short or no length passwords, and do not apply character set or encoding restrictions on entry or storage of the credentials. Now we all know that the minimum password length in probably 70-80% of the applications right now is only 8. Now when I say that the minimum password length is 8, me being a human would only give a password which is of 8 characters, or at the max 10 or 11, just to meet that criteria. Now a criteria would be having an uppercase, a lowercase, a special character, and a number. Now because we have this human psychology of having everything the first letter as capital, like I would like to play a small game with you right now. Now in your mind, think of the application which is very critical for you, maybe a banking application, maybe Facebook or anything. Now how many of us would have the first letter of a password as a capital letter? Probably most of us, followed by few lowercase letter, followed by a special character, most of the times at the rate, followed by a number, let's say 1 2 3 4 5 6 7 8 9. Now this is a pattern that almost all the humans on earth would follow if I ask someone to set a password for 8 characters. Now if we increase the character length to, let's say 16, the minimum password length to 16, now the users would have to use a passphrase rather than a single word followed by @123. Now this is called as a password topology. Password topology is the one that I just mentioned, that we always have the first letter at capital followed by small letters, @ and number. So the attackers already know that this is the human psychology, and most of the users have their password in such a way. So it becomes easier for them to crack such passwords. They create combinations of password like the first letters capital and blah blah blah, and they start brute force attacks on your application. So it is very important that we also have account lockout features on our application. Like let's say after 3 or 5 unsuccessful login attempts, the user would be locked for, let's say 24 hours or 30 minutes, depending upon the criticality of the application. Now, if you ask me, a reasonable long password length is 160. I've never seen an application which has a password length of 160 or supports a password length of 160. And they also don't support special characters like greater than or less than symbol or single quote in a password, which probably most of us might have seen that whenever we see a password guideline on the screen, they always say that you can use everything except for greater than, less than, and a single quote. Now, the reason for that is probably they are too scared of their database breach because of these characters, or they're way too lazy to secure code. Now, ideally, a minimum password length should be 16. A maximum would be something between 32 to 64. Now, when I restrict my users to a certain limit of minimum password length, I'm actually restricting them to have a secure password. Now, what if I want to have a password of, let's say, 32 characters, but the maximum length in your application only 16? So for me, that might not be a safe password. So you should always have the maximum length as 32 and minimum as, let's say, 16. And let's say if you're using a very old hashing algorithm and you want to update it to a newer version, the link that I've mentioned on the screen is a very good blog on how to upgrade your hashes. Or let's say if you're encrypting your passwords in the database and now you have to move on to hashing, then you can make use of this link or this block on the screen right now. The forgot password is probably the most underrated feature, I believe, in any application or development process. Because probably how many of us would believe or think that the current forgot password questions that we see or security questions that we see on the screen on any application are something which only we would know, and we are not posting it day in and day out on Facebook. Now, the most common security question to reset a password is, what is your mother's maiden name? Now, that's something which you can actually guess or take from someone through social engineering attack, or that's something which probably someone might have posted on Facebook as well. So if you want to create a secure design for forgot password feature, there are a few characteristics that your security question should follow. The first one is memorable. That is, if users can't remember the answers to security questions, then we have actually achieved nothing. Consistent. The user's answers should not change over time. But for instance, asking what is the name of a significant other may have a different answer probably 5 years from now. Nearly universal. The security question should apply to a wide audience wherever possible. And of course, safe. The answers to the security question should not be something that is easily guessed or researched. Example, something that we post on public records, Facebook, Twitter, Instagram, everywhere. So I've come up with a list of secure passwords, which I believe fall or are aligned to the characteristics that we just saw. So I'll give you like 5 seconds to go through them. We rarely see these security questions while resetting passwords, unfortunately. But if now that you know the characteristics, if you're developing an application, just make sure that these are the questions or like similar questions which follow the characteristics that we just discussed in your forgot password feature. The next proactive control is data protection privacy. Now, most of us on the call are privacy advocates, or they know what privacy is. Now, when we talk in terms of application security, HTTPS is the term that comes to us when we talk about data protection and privacy. HTTPS stands for Hypertext Transfer Protocol Secure, we all know. Now, what benefits do HTTPS provide? Confidentiality, integrity, and authenticity. Now, we all know confidentiality is no one can view your data. Integrity is no one can change your data. And authenticity would be the server that you're visiting is the right one. Now, to give you a quick real life example on authenticity, There's a bank in India called as HDFC Bank, if you have not heard about it. So the net banking feature of HDFC is a two-page login process. When you go on netbanking.hdfc.com, it will ask you a customer ID first. Now, when you enter a valid customer ID and say submit, you would be taken to the password page with the image that you have selected when you registered. Now, for HDFC, they say that it's the authenticity part that we are giving to the users so that the users are confident that they're indeed on HDFC's site because they entered their user ID and they were redirected to the password page. Now, if you think in terms of an attacker, you see a username enumeration attack possible on the login page of HDFC, where you try to brute force a lot of customer IDs, and for whichever customer ID you see a password page, that customer ID is valid in HDFC's database. Now it has its own pros and cons, but for HDFC, the rationale is authenticity is what they provide to the user so that the users know they are indeed on hdfc.com. Encryption in transit, very important. Now, when should TLS be used? From login to the logout, everything should be on SSL. Now, there can be instances where my help page is on HTTP, and once the user clicks on the help hyperlink, I'm redirecting him to another website where I have all the help pages listed. Now, that would be an HTTP. Now, in that case, it is very important that I use a security header which is called as HSTS or HTTP Strict Transport Security. Now, it's a very interesting header. You all should read about it. Now, what happens here is if the browser sees that the server has responded with the HSTS header, the browser itself creates a secure channel to the server. Now, even if by mistake or unintentionally I type http example.com, but because the server responded with an HSTS a while ago, the browser would itself create a SSL channel for till the server, and your data still goes over SSL. So HSTS is one of the best security headers right now. Uh, it helps you to add an additional layer of security in your application, but not having that is not a vulnerability. But it is always recommended to have an HSTS header implemented along with content security policy, HPKP, and all other headers. Very interesting uh, theories around that, and I would definitely recommend all of you to read about security headers. Few of HTTPS configuration best practices, again OWASP and SSL Labs, very good websites. The next proactive control is error handling, logging, and intrusion detection. Now, you won't believe, but we can actually turn our applications into a intrusion detection system with the help of logging. Now, how can we do that? Now, let's say there's an input validation failure on the server side when the client side validation exists. Now, I have certain client side controls that a phone number field should only have numbers and not characters. But still, the server received a request where the phone number had characters. This means that someone has tried to bypass the client side controls and the request had reached the server. And you can treat it as a detection that someone is trying to do something malicious. Second is input validation failure on the server side on non-user editable parameters such as hidden fields, checkboxes, or radio buttons. On the client side in my application, I only have 4 radio buttons or four drop downs in my menu. But certainly when the request reaches the server, it might have 5 radio buttons, with fifth one being a script tag. This means that someone has tried to change something on the client side and see what the server responds. The next is forced browsing to common attack entry points. Let's say if all the users should see /home /index.jsp, but someone is trying /admin /index.jsp, and the request reaches the server, then someone is trying to force browse or perform privilege escalation attacks and trying to see if they are able to view the admin's page or trying to see the robots.txt page. So this is something where you can detect that a malicious attacker or hacker is trying to do something with their application. Others would be an SQL injection or XSS attack, like you get scripts and single quotes in input fields where they are not expected. Workflow sequence abuse, multi-part form in order. For example, if I have a registration page for user, which is divided into 3 pages. So on the first page, I take his name and few other details. On the next page, I take, let's say, his passport, scanned copy or something like that, or documents. And the last page would be I show him all the details with an acknowledgement. Now, let's say someone just enters the first page and he is now directly on the third page without uploading his or her document. It means that there has been a workflow sequence abuse where someone has tried to reach the last page instead of the second page. The next is custom business logic failure. Now let's say if you are shopping on a website and when you select that item to add to your cart, let's say it would be of $100, but when you go on the checkout page, it show you $10. So that means that there has been a mismatch in the price of the cart and what you see at the checkout. So that might be an indication that someone has captured the request and changed the price of that item from $100 to $10 and seeing if the server accepts it. Error handling, very important. Uh, Most of the times what I have seen while pen testing is the developers display the entire stack trace on the screen for the end user on the browsers, which gives a lot of technological information about what the application is using, including the database, the open source software, the language that the application is built on, the line number. We all might have seen that. So it is not recommended to display or print stack traces on the screen ever. It is always recommended to have generic errors like system error, please try again later, or there was an error, contact administrator. Never give out any detail about our application on the screen for the end user. Now, if you give that, then the attackers would know the technology that you've been using and they can have targeted attacks depending upon the technology. Now, if I don't know the database that you're using, I'll have to try all the possible databases to see what errors I'm receiving. And if you give me that particular error, let's say an Oracle error like ORA, I would know that the database being used is an Oracle. It's always recommended to give generic error messages on the screen. Few examples like Java best practices, uh, pretty self-explanatory, the try catch block. We only log the errors and we give out a message on the screen like an error occurred or contact an admin, but never e.print stack trace should never be given in the code unless it's a lower environment and you want to debug the application. But when it goes into the production, that line should be removed. Best practice for .NET, again, a similar thing, throwable T. Uh, we log the severity that something bad happened, but on the screen we say that just contact the admin. So it is very important to log your failed as well as successful attempts. We'll see that in a bit. All right, the last proactive control is leveraging security features of frameworks and security libraries. Now, most of the times when we try to customize or build our own authentication or password storage or cryptography code, we mess up, unfortunately. So it is recommended to use open source frameworks and security libraries which have been developed by security researchers and experts over the years, and they're very good. Now, one of them is Apache Shiro, a powerful and easy to use Java security framework. Again, it offers you solutions for authentication, authorization, cryptography, and session management. Built on sound interface and object-oriented principles, enables custom behavior and sensible and secure defaults for everything. Now, instead of creating your own code for cryptography, it would be better if we use the open source library readily available. The next open source library is libsodium. Uh, it is very good for encryption, decryption, signatures, password hashing, and more. So instead of building your own code for password hashing, you can use the libsodium library. It is cross-platform and cross-language supportive and runs on a variety of compilers and operating systems. Very good library. I've worked on it myself. So it's always recommended to use libsodium. Right, we have come to the last or probably second last slide. So if you've been through all the past 1 hour, you would probably agree to what I've mentioned on this last slide. It is whenever you're coding, trust nothing, validate everything, think like a hacker, and stay risk aware. With this, we have reached the very last slide. I have all my details on the screen and I'm open to questions now.
Okay, thank you so much, Prasad. That was a really deep technical knowledge. I myself learned a lot today, a lot of things which I just knew a few words, but now it makes more sense. And I think I can talk better to that now. Perfect. So we have one question with us now. That's from Heidi. She says, when interviewing prospective vendors to build an application, what are the key or the top 3 questions that we should be asking the vendors in relation to secure coding?
Probably the first thing that we should ask them is, do they have a secure coding, or do they have an application security team in the first place, and do they have standards related to secure coding? Do the developers go through a secure code training, either online or instructor led? And uh, if they go through an instructor led or online training, we would like to see if we have an exam at the end of that session and the scores of all the developers. That's probably the top 3 things that come to my mind right now. But there are a lot of things, but top 3 would be, yes, if they have a policy in place where it is mandatory for every developer to go through a training and also apply that. Are they performing static code analysis? Are they scanning and analyzing and fixing? Now, a lot of organizations only scan, but they never fix. So we should always ask them that, do they perform static code analysis and fix the findings that a static code analysis has given? And if they have like a CI/CD pipeline, have they implemented all the security checks in that pipeline as well? So,
Okay. Heidi, does that answer a question? I hope it does. Perfect, Heidi says, thank you. Okay, so we have another question from Dr. Reem. She says, when it comes to making security as invisible as possible to users and having at same time secure coding and passwords, what options do we have?
uh, the first thing that I would say, that never depend only on the passwords. We should always have multi-factor authentication in place. So if you only depend on passwords, then probably that would be an internal application. But if it's like internet facing application, it is always recommended to have a sort of MFA, like an OTP, and the minimum password length, as we have discussed in the session, should at least be 16, and the maximum password would be 32 to 64. Now, a lot of users don't like the multi-factor authentication part, but for security purposes, we have to give. Now, if you want to make an invisible security, then I would say that the only option that we have is to increase the minimum length of password to at least be, let's say, more than 20. And then you have to make sure that the users are comfortable setting those passwords, and also use a very strong hashing algorithm to store them in your database.
Okay, so Dr. Reem, does it answer your question? Do you have any follow-up question to that before we move on to our next question? Reem says, thank you. Okay, so we have a next question. Okay, sorry, Fatima, I missed your question there. If we are using MFA, then why should we use a strong password?
All right, so that's a great question. So whenever we say that MFA has been implemented, now of late you might have heard about the SIM swap attack, wherein even the OTPs are being hacked by attackers by the SIM swap attack. So let's say there might be instances that the OTP functionality goes down, or the SMS vendor that we have been using, there's some issue, or the SMS vendor itself gets hacked. Now, there might be like a day or two where we only have to depend upon our passwords. Like, so defense in depth is what I'm trying to say. Now, if I don't have strong passwords and I'm only depending on MFA, tomorrow something happens for the MFA vendor, then I might have to only depend on the password. If I have strong password, then yes, I'm making it difficult for the attacker to guess it, and at the same time to hash it with a strong password hashing algorithm. Now, if you go by the latest NIST password guidelines, they are saying that you should never force your users to have maximum length password. I mean, the user is free to have their own length of password. Even the users can have a 6-character password, it is fine. But again, that depends upon the application that you're building and how critical it is for you to safeguard the data of your customers.
Thank you, Prasad. Okay, so the next question is from Abir. What's a good obfuscation tool you recommend for mobile apps? A tool that is not too expensive to require of the software vendor.
I haven't really worked on a lot of mobile applications, unfortunately. So most of the times I worked on Java or .NET. So I wouldn't be in a better position to answer that question right now.
Okay, no worries. The next question we have is your views on the usage of CAPTCHA. What are the best practices?
All right. For CAPTCHA, I would say there are 3 best practices if you ask me. The first one is your CAPTCHA is random enough every time you give out unique values. Secondly, you're actually checking that CAPTCHA. Now, if I think from a pen tester perspective, what I'd like to do is probably see if the server is actually checking the CAPTCHA that I've given. Now, I could capture that request in a proxy tool, change the CAPTCHA, or probably delete the entire CAPTCHA and its field value, and try to see if the server responds back. I could try to use a previously given CAPTCHA and try to replay that. Now, the best practices for me would be once the CAPTCHA has been utilized, you're invalidating that so that no one can replay. If someone tries to send a blank CAPTCHA, you throw out a generic error, and the CAPTCHA is of a good length, let's say as a good combination of letters and numbers. So those would be like the top 3 for me for CAPTCHAs.
Thank you. Okay, so the next question is from Sonia. She says, what controls can we put for administrative interfaces of any web application?
The first foremost is never use default credentials out of box like admin or root. Uh, for admin, it is always recommended to have a very strong password again, like 16 or like 32 characters minimum. And again, there should be an admin should always have 2 accounts. Like one would be an admin account and the second would be a normal account. Now, the admin account should only be used where there is a need, like on a need to use basis. If there's something to be changed in the application or added in the application, then you should log in with the admin role, and everything that the admin is doing should be logged. So like if you ask me the top 3, it would be changing the default credentials, having a strong password again, and logging everything that the admin is doing. And the fourth one would again be having two accounts. An admin account should only be used on need to use basis.
Okay, the next question goes, what controls should be put in the contracts when procuring a software?
For procurement, again, I would think about how secure that application is. Do they go perform static analysis? Do they perform or have they perform a pen test? Probably from an external vendor. I would like to see their reports. How many high-risk vulnerabilities that they have in the application? What are the plan to be on those to be fixed? What are the open source softwares and their versions that they're using in the application? What is their password policy? So a lot, I mean, you can have a big checklist depending upon the application that you're procuring.
Yeah. And is there, sorry, Prasad, just on that, is there or are you aware of any good reference sources where people could look for some certain checklists like this?
Yes, so as I mentioned in the beginning, OWASP Application Security Verification Standard, OWASP ASVS, it has around 200 plus security requirements. So it can be used as a checklist as well. So depending on the application you're procuring, you can go through that ASVS document and ask questions on that.
Thank you. Okay, the next question is from Fatma. She says, what are the use cases for CAPTCHA?
Use cases for?
CAPTCHA.
All right. Well, as I mentioned, the three again to see if the CAPTCHA is pretty unique. At least 6 characters with a combination of uppercase, lowercase, and number. Uh, the CAPTCHA shouldn't be replayed. Now, if let's say I get ABC123 as my CAPTCHA, once I've entered that, the server should invalidate that. Now, I cannot again use ABC123, even if on the screen I'm seeing XYZ456. So a previous CAPTCHA shouldn't be used. The last would be to capture the capture request in a proxy tool and delete the entire capture field. Now let's say the request is username Prasad, password Prasad, captcha ABC123. I remove the and captcha ABC123 part completely, and only username and password is passed to the application to see if the server responds back positively or negatively. So this is what I usually try in while pen testing. The same thing goes for CSRF tokens as well, not only capture.
Thank you. Okay, the next question is from Dana. She says, every security action has a cost. What is your method for measuring which coding security actions to use and when?
Well, I would recommend that all the proactive controls should be used in your application if it is a critical application. But again, it completely depends upon what sort of application. Now, if there's an application which is going to be used only by my employees in an internal controlled environment, only through their laptops, let's say SSO with their LAN credentials. So in that case, I might not have all the security controls in there, but something which is internet facing, which like the bread and butter for the organization, I would recommend all the proactive controls that we have discussed so far should be used. Because if we don't, then probably we might end up having a database breached or reputational damage or paying hefty fines to regulators.
Thank you. Okay, so the next, so Sonia has another question. She says, how can we accomplish out-of-band connection to web applications?
Can you repeat that, Priya?
How can we accomplish out-of-band connection to web applications?
Well, for out-of-band connections, it is recommended to always have a security header called as content security policy. Now, when I go out of band, it means that I would be loading something which is not part of my domain, or someone is loading content in my domain. So in that case, it is very important to have a content security policy. It is again a security header. Now, for instance, if I'm loading a script or jQuery from jQuery.com images from Google Images. So I would want to have a content security policy which whitelists all these sources, like the script source, the image source, my child sources, or anything who is allowed to have out of band connection to my application and vice versa. It is always recommended to have a content security policy header. It is need of the hour.
Right. So let me just do a double check. I think this is where. Okay, so we have another question from Fatima. She says, as of now, we're depending on application as SaaS, yeah, SaaS applications. How can we perform application security testing for these applications?
For software as a service?
Yes, software as a service.
Well, that again depends upon, I mean, you're providing or you're, I mean, you're at the receiving end or you're the provider of software as a service.
From our question, looks like they're using the application, so they're the clients.
Okay, then in that case, again, if the client allows, we could have a pen test done, or we can ask the client for the pen test reports, both internal and external, performed by well-known vendors, and go through their reports. And before, again, the same question about the procurement. Before we procure any software, it is important that we understand their security culture, uh, their secure coding practices. How are they fixing the vulnerability? Like, let's say they might have a high risk vulnerability, but that might be reopened after a month. This means that they did a band-aid approach. They didn't did a foolproof approach to fix that vulnerability. They only did it for the time being. So these are different factors that we could consider. So the number of high-risk vulnerabilities or critical vulnerabilities they have, open source softwares and their versions, because that is very important. Open source softwares is something that is not in our hand as developers because they are open source. Now, if there's a vulnerability in that open source software and I'm consuming that in my application is vulnerable. So it is very important to have an up-to-date open source softwares being used in your application, which involves jQuery as well, for example, or Spring Framework. And again, the vulnerabilities, how they are fixed, what approach they have taken, how long did it take to fix their vulnerability. So it shows their culture of security as a whole.
Yes, and then just to add to that, Prasad, what I have found helpful is at minimum, if we are using a software as a service, at minimum, we should definitely ask for the last security test report of that application.
Yeah.
Because as the pro service or the solution provider, they should have done a security testing by themselves. Yeah.
Yeah.
And second is we need to understand what's their secure coding process. If that's a development house, then definitely we should understand whether they take it through the life cycle or not.
Yeah.
I think those two things are at minimum. We should ask from all the software providers when they say it's a cloud hosted solution or we host it on our end and just sell it as a subscription.
Absolutely. And there's also a very good site called as securityheaders.com, wherein, I mean, it's internet accessible. So let's say if you want to check, uh, I'm a potential customer and I go to abc.com and I like their product. Now I want to use it. They have a web application. Now what I can do is I can just go to securityheaders.com and enter the URL of that application and just say scan. Now securityheaders.com would in return tell me all the security headers that the application is implemented depending upon the response that it has received. That's why we always say that the security headers should also be implemented on the login page. A lot of application, once you log in, you see all the security headers or everything related to security implemented. But on the login page, a potential client could go to securityheaders.com, and if you have none implemented, that would be a bad impression on the client that there's no security in this application because I don't see any security header, though you have implemented them after the login. But at the first impression, it looks like you haven't. It is always recommended that from login to logout, everything should be secured.
Thank you, Prasad. That brings us to the end of the questions. I'll just give another minute for everyone just in case if there are any last minute questions for Prasad.
Sure.
So Prasad, I have a question.
Yeah.
So now that most organizations are moving from their on-prem hosting to a cloud hosting, yeah. So it's quite possible that the controls that may have been relevant while hosting it internally may or may not be as relevant on the cloud, right? So what would you suggest that we recommend to the users or the developers for that sake on what are the precautions or what are the checks they should do on controls when planning to move to the cloud?
Well, so nowadays the very famous cloud providers like AWS, Azure, or Google. Now, let's say if I want to move my on-prem things to, let's say, AWS cloud. Now, it is important that I understand the security policies that AWS would be providing me. Now, again, depending upon what sort of cloud structure I'm going for, is it infrastructure as a service, platform as a service, or a software as a service, the things that the cloud provider would do and I would be doing as a customer would depend upon what sort of cloud methodology I'm going to use. So at the minimum, if let's say if it's an infrastructure as a service, then again the task of securing would be at my end. But if it's like a platform as a service, then I would depend upon uh, AWS to provide me a secure environment. And again, for my users, I would want them to have a swift transition from the on-prem to the cloud environment, because again, on cloud, it's always available. Anyone can log in anytime they want. So again, MFA would be something that I would definitely require my users to have on the cloud infrastructure. And again, continuous patching, uh, all the things that we do on-prem should be replicated on the cloud as well, depending upon the that it's PaaS or SaaS or infrastructure as a service.
Okay, so seems we don't have any more questions. So before we end the session, thank you so much once again, Prasad, for your time. And it was a really good session. So thank you so much again for sharing your knowledge. Okay, perfect.
Thank you.
Thank you so much. Thanks, ladies. Take care.
Thank you for inviting me.
Thank you, dear. Take care. Bye
Thank
bye.
you. Bye bye.
Okay, and everyone says thank you to you too.
All right. Thank you, everyone.